Good evening, class. Today what we're going to focus on is surface area of prisms and cylinders. So before we actually start looking at prisms and cylinders again, let's first of all talk about what surface area and what nets are. Surface area is the sum of all the faces of area. So if I had like a cube here, if I added up this area, this area, this area, this area, this area, and this area, that would be the surface area because I added up each face's area. This, if I wanted to find its surface area, I'd have to add up each of these faces around the edge and the front and back. That would be the surface area. It's the sum of all the faces area. I can find each face individually, or I can make something like a net to find it. Now, a net is a two-dimensional representation, right here, of a three-dimensional object. It's like as if we cut the shape apart and we unfold it. So, for instance, this side here was 5, and you'll notice that this length here was 5, and this length here is 5. The height is 2, so the height is 2 here, here, and here. The length was 6, so this part here is 6. So, it's a two-dimensional representation of a three-dimensional object. Basically, we cut it and we unfurl it. So, what if I had this example problem? Find the surface area of a 4-meter long cube. So I gave you a picture to help you see it. But let's make a net of my picture. So what I did to my cube here was I essentially cut along the top here like this. And I did the same thing on the bottom. And then I cut right here. I pulled this edge out. I pulled the front to be here. At the top I folded up, at the bottom I folded down. And that's a two-dimensional representation of my cube. Now I want to find the surface area. So I could find each cube individually, or I could do stuff like length or height times base. So these four combined would be 6 times 6 plus 6 plus 6 plus 6, or 24. So 6 times 24 is 144. And that would be the area of these four. Now, the area of this one is 6 times 6 because it's a cube, so this is 36, this is 36. So my final here would be 144 plus 36 plus 36. So it's basically find the area of each one individually. And what I end up getting is 216 units squared, because surface area is measured in units squared. But I realized I was given units. Meters squared. And there we go. I just made a mistake. I was doing this. I did the problems assuming that each side was 6 meters. Each side was 4 meters. So if you're wondering why there's a difference, it's because I messed up. It's supposed to be 6 meters, not 4. So my picture there is wrong. It should be 6. If you did it using 4, you should have got 96 meters squared. So this is if you did it using 4. And if you did it using mine here, you would have got 216. Alright? I made a slight mistake, my bad. Alright, now we're going to look at a prism. We're going to be a little bit clear with a few things here. First things first, a base is parallel to the other side, or the other face, I mean. So face to face, parallel, and it's connected by quadrilaterals. Face to face, parallel, connected by quadrilaterals. Now there's a reason I said quadrilaterals. That's because this is still a prism. These are parallel, and they're connected by quadrilaterals, not rectangles. Now if it's this type, it is rectangles, but if it's this one, it's parallelograms. So, the lateral face is the sides, the faces that are not the base. So in this case, these two are the base, so these sides are the lateral faces, basically the quadrilaterals of a prism. The lateral edge is any edge that connects two lateral faces. And a base edge is an edge that is between a base and a lateral face. That's really the new terminology. So there's one last one that we have to go over. These two are both triangular prisms. They both have triangle as a base. However, there is a difference between the two. This one is the one I'd probably rather work with, but I can still work with this one here. Now, this is called a right triangular prism. Right, because when I set it down, it'll form a right angle with the ground. Or, in other words, each lateral face is perpendicular to each base face. Each lateral face is perpendicular to the base face, meaning that here, on this edge, on this side, on this face and this face, they are perpendicular. That means there's a right angle between this face and this face. Here, between this face and this face, it's definitely not a right angle. So we call this one oblique triangular prism. Right triangular prism, oblique triangular prism. Means it does not meet at a right angle. Means if it's a right triangular prism, it means it meets at a right angle. To find the surface area and using the formula, it only works for right prisms. So if you try using this formula for this shape, the oblique one, it's wrong. You can't do it. You're going to have to use the net. Okay? You can't do this formula for anything but right prisms. And here's the ideal. Well, the surface area will be the base plus the base. Good so far? Makes sense. So 2 times the base will be the area of those two. But to get the area around here for these three, I can take the perimeter and multiply by the height. Perimeter multiply by the height. So if I call this side 1, side 2, side 3, if I did side 1 times height plus side 2 times height and side 3 times height, and I factored out the height, I would get side 1 plus side 2 plus side 3. So when I look at the formula for the surface area of a prism, I realize it is 2 times the base area plus the perimeter times the height. But how does that actually work? Why do I get perimeter times the height for that area? Well, base area plus base area, top and bottom, makes sense. Base area plus base area is 2 base area. But now, how do I get perimeter times the height? Well, if I look at this, if I would do this rectangle, that rectangle right here, its area is S2 times H. If I would do the middle rectangle, that's S1 times H. And if I do the last rectangle on the left side, that's S3 times H. Well, if I factor out an H, I get side 2 plus side 1 plus side 3. Which, if I add up all the sides of my base, that's the perimeter of the base. So instead of writing it that way, why don't I just write it this way? 2 times the base area plus the perimeter times the height. And there we go. That's the equation for the surface area of a prism. We do write it another way sometimes. Instead of writing 2 times the base area, because I know the base area is a regular polygon, the area of the base is 1/2 A times the perimeter, or the apothem times the perimeter. So I can plug that in, and I'll get apothem times perimeter plus perimeter times the height. Honestly though, we'll be using that one more. Alright, and there we go. That's the surface area of a prism. And at this point, we just kind of need to know it and apply it as necessary. So, what if I said, find the surface area of a triangular prism with height 5 meters and side length of 4 meters. Now, the first thing I would do here is I try to draw a picture. I would draw a triangle for the top, I draw a triangle for the bottom, and I would connect them using quadrilaterals. I'll dot whatever I can't officially see, and I'll have my shape. Now, it said it has a side length of 4 meters, which means this is 4, this is 4, and this is 4. This is 4, this is 4, this is 4. The height is 5 meters. So I look at this. Perimeter. Oh, the perimeter of the base is 4 plus 4 plus 4. So the perimeter is 12 meters. The height is 5 meters. And the only one I need now is the base area. If I know the base area, I'm good to go. Oof. So I need to find the area of the base. Well, how do I find the area of an equilateral triangle? Well, 4, 4, 4, dotted line here, right angle. What's the height of my equilateral triangle? Oh wait, if it's equilateral and I just drew an altitude, I just cut these two in half. That's 2, that's 2. And I need to know the height of this, or x. So wait, I am looking at the right triangle. So if I just look at this, a squared plus b squared equals Pythagorean theorem. 2 squared plus x squared equals 4 squared. Solve for x, I get 4 plus x squared equals 16. X squared equals 12. Square root both sides. X equals square root of 12, which I'm going to put this in the simplest radical form. So factor tree, I get 4 and 3. Factor 4, I get 2 and 2. There's a pair of them, so I pull them out. So x equals 2 square root of 3. So that's the height. The area of a triangle is 1/2 base times height. The base is 4. The height is 2 square root of 3. The area is 4 square root of 3. And quite honestly, I'm fine with you leaving that square root of 3 tagging along. So it's meters squared. 4 square root of 3 meters squared. So that means my base area is 4 square root of 3 meters squared. So wait. Now that I found the area, I knew the perimeter, I knew the height, I found the base area, and I know the formula for the area of the surface area of a prism. And that's what I was looking for. So now it's just time to take what I found, or knew, or figured out, and plug it into my equation. So the surface area equals 2 times the base area, 4 square root of 3, plus the perimeter 12 times 5. So what I get here is the surface area is 8 square root of 3 plus 60. And at this point, I'd probably just punch it in my calculator so I don't have to deal with an addition sign at the end. And I got 73.86 meters squared. And there we go. That's how you would do a problem like this. The hardest part is probably going to be finding the surface area, because it's always going to be a regular polygon whenever we're doing this. So the perimeter is just the number of sides times the side length. The height is whatever they tell you it is. And then finding the area, you're going to have to do something like this, or you're going to have to go back to section 6 of chapter 11 and figure out how to find the area of a regular polygon. That's it for prisms for now. We'll come back to them later. But we're now going to look at cylinders and its surface area equation. So, with a cylinder, it's a shape that's like a prism in that it has two bases, a top and a bottom. But each base now, instead of being a polygon, it's a circle. So when I look at this shape here, it looks like maybe a soda can, maybe some sort of vegetable can, or aluminum can. But either way, circle top, circle bottom, connected by a face. So this here is a cylinder because it has two bases that are circles that are parallel to each other. The height will be the distance from or between those two circles. And the radius is the radius of the circle. And that's a cylinder. This is still the lateral face. These are bases. Alright? So, to find the surface area of a cylinder, I look at it, and here's the equation in red. It'll be a surface area equals 2 times the base area plus the circumference times the height. Hold on a second. That's the same equation as the prism. Just instead of perimeter, we call it circumference because it's a different word. That's true. It's the same equation, just instead of saying the perimeter of the circle, we say circumference. Yeah, it's the same exact way to find it. But hold on. The perimeter? So how does this end up being this times the height? Well, if we think about this as a piece of paper here. If I would take a piece of paper, such as this one here, and I put it around here. Well, this distance around here is the circumference. And the height of my cylinder will be the height of the piece of paper. If I would unfurl this, what would happen is the bottom would be the circumference, and the top would be, or this part would be the height. So this would be essentially multiplying the base times height of a rectangle. And that's why I get circumference times height for that part. Now, I know the circumference of a circle is always 2 pi r. So why don't, instead of using c, I use 2 pi r h. And I know the area of a circle is pi r squared. So wait, my equation can be simplified down to this? Yeah, it can be. And in fact, this is probably the equation I would suggest you using. Because it's going to be easier to find the base and the circumference if you already know that all you're looking for is the radius of the circle. If you know the radius and the height, you plug it in and you've got the surface area. Alright, so at this point, let's look at a few examples, or let's do a few. Example 3. Find the surface area of a cylinder with a 6-meter diameter and a height of 3 meters. So, real quick drawing of my picture, I get 3 meters for the height, 6 meters for the diameter. But I'm looking for, well, for my equation, to find the surface area, I need r, and I need r, and I need the height. So if I know the radius and the height, I just plug it in. Well, if the diameter is 6, then the radius is 3. So wait, the radius is 3 and the height is 3? Just plug them in. So r equals 3, h equals 3. At this point, all I do is I plug in my equation. S equals 2 pi r squared plus 2 pi r. H. Plug 3 in for the appropriate spots. 2 pi times 3 squared plus 2 pi 3 times 3. Simplifying the left one, I get 2 times 9, which is 18 pi. And over here I get 2 times 9, which is 18 pi. So my answer for the surface area would be 36 pi meters squared. And unless they tell me to round it, I'm fine with that answer. Now for those of you that like decimals, or if it says just find the surface area, giving me an exact answer or a rounded answer is fine. I prefer exact though. And if you round it, that's what you get. 113.10 meters squared. That's it for surface area of a prism. Sorry, of a cylinder. I find this to be a little bit easier than the prism, just because the prism can have shapes that are a little bit harder to find with area of the base. But these, if you know R and you know H, it's pretty much plug it in and you're done. Alright, example 4. It's a word problem. It says you are wrapping a stack of 20 compact discs using shrink wrap. So maybe you're shipping it somewhere, maybe you're owning a business and you're trying to use shrink wrap. But you want to know how much you need in some scenario. So, what we're doing is trying to calculate how much we need. It says you are wrapping a stack of 20 compact discs using shrink wrap. Each disc is cylindrical with a height of 1.2 millimeters and a radius of 60. So this here, it's a very small cylinder with a height of 1.2 and a radius of 60 millimeters. So this is kind of small. What is the minimum amount of shrink wrap needed to cover a stack of 20 discs? Wait, if I'm stacking 20 discs, that means I added another one here with another height of 1.2 meters or millimeters. I added another one and another one and another one. A total of 20. So I could really just draw myself one picture here. The height of 20 of those discs put together, well, that's just 20 times 1.2, or 24 millimeters. They told me the radius was 60 millimeters, and basically they're asking how much shrink wrap is needed. Well, shrink wrap is around the edge or the surface of my cylinder, so basically they're asking me for the surface area. I know R is 60, I know H is 24, and I know the equation. S equals 2 pi r squared plus 2 pi RH is the equation to find the surface area of a cylinder. So I know R, I know H, I know the equation. Wait, if I know r and I know h, and this is the equation, don't I just plug r and h in appropriately? Yeah. So, surface area equals 2 pi times 60 squared plus 2 pi 60 times 24. And then we simplify what we can. So, that's going to be 3,600 times 2. I get 7,200 pi. Plus, over here, I get 2,880 pi. Add those two together, the surface area ends up being something real close to 10,080 pi millimeters squared. Or, when I plug it into my calculator, now it's not exact, it's rounded, but it ends up being about 31,667.25 millimeters squared. And there we go. That's it. That's how much shrink wrap I would need. Now, if I knew how much it costs per millimeter squared or per meter squared, I could then do more calculations to find out how much it would cost me to shrink wrap this set of 20 discs. So either way, using the net to figure out each individual area, or using the equation, if done properly, you should get the same answer. Well, that's really it. That's how you find surface area of prisms and cylinders. Cylinders I find a little bit easier because if you know R and you know H, you just plug it in and you're good to go. The prisms are a little bit tougher because you have to find that base area individually. Well, that's all I have for you today. Till next time.